Hello, everyone. Good afternoon. I'm Julie Pearl Espinosa, and together with my partner Mary Rose Quizon, we are going to discuss about quality management. This is based on Grizzly's project management approach. Okay, so during the past 20 years, there has been a revolution in quality. Improvements have occurred not only in product quality, but also in leadership quality and project management quality. Unfortunately, it often takes an economic disaster, a recession, or downturn in a firm's business based to get management to recognize the need for improved quality. Okay, so first, let us discuss what is the meaning of quality or what is quality management. So, quality is defined by customer. So yes, it's true because this should be based on the customer's specification. So if we are the customer, so it should be within our specs. No, the product that we bought should agreed on our terms. Okay. Now, based on Kodak, quality is those products and services that are perceived to meet or exceed the needs and expectations of the customer at a cost that represents outstanding value. Well, based on ISO 9000 definition, the total quality of the totality of feature and characteristics of a product or service that bears on its ability to satisfy stated or implied needs. So terms such fitness for use or customer satisfaction and zero defects are goals that rather than definitions. So most organizations view more as a process than a product. The more specific it is a continuous improvement process where lessons learned are used to enhance future products and services in order to retain existing customers, win back lost customers, win new customers. So therefore, companies are developing quality improvement processes. So based on this Kodak's five quality principle, so there should be a continuous improvement. So from the customer focus or then the analytical approach, the teamwork, and the leadership. Now, let us look at the quality movement or how does the quality evolve. Okay, prior to World War One, quality was viewed as inspection or sorting out the good items from bad. Then after that, around early World War One to early 1950s, the quality evolved to quality control principles, or wherein quality control principles were molded. Okay, these are the statistical and mathematical techniques, sampling tables, process control charts. So these are the processes that or principles that were used to enhance the quality. Then from early 1950s to the late 1960s, quality control evolved into quality assurance with its emphasis on problem avoidance rather than problem detection. So additionally, quality assurance principles emerged such as the cost of quality, zero defects programs, reliability engineering, and the total quality control. So today, emphasis is placed on strategic quality management, including such topics are um, quality is defined by the customer. It is linked with profitability on both the market and cost sides, and quality has become a competitive weapon and now an integral part of the strategic planning process. And it requires this quality requires an organization-wide commitment. So there are three most influential quality experts. So these are W. Edward Demings, wherein he was able to um, create or he was able to show the process of evolving the quality. This is what he called the Deming cycle of improvement. So the PDCA cycle, the plan, do, check, act. Okay, so Deming believed that the reason companies were not producing quality products was that management was preoccupied with today rather than the future. So Deming postulated that 85% of all quality problems required management to the initiative and change the process. Only 15% of the quality problems could be controlled by the workers on the floor. As an example, the workers on the floor were not at fault because of the poor quality or raw materials that resulted from management decision to seek out the lowest cost suppliers. So management needed to change the pursuing policies and procedures and develop long-term relationship with vendors. So processes had to be placed under statistical analysis and control to demonstrate the repeatability of quality. So furthermore, the ultimate goals should be a continuous refinement of the process rather than quotas. Okay, so while Joseph Duran Dr. Duran began conducting quality control courses in Japan in 1954. So, 4 years after Dr. Deming, Dr. Duran developed these 5 steps to quality improvement. So, these 5 steps quality improvement are building awareness of the need and opportunity of improvement, setting goals, organize to reach the goals, and provide training, carry out projects to solve problems, report the progress, give recognition, communicating results, and keep the score, maintain the momentum of making annual improvement. So other than the 10 steps of quality improvement, they Dr. Duran also had the quality, what you call it, the Duran trilogy. So these are the quality improvement, quality planning, and quality control. So Duran stressed that the manufacturer's view of quality is adherence to specification, but the customer's view of quality is fitness for use. Duran defined 5 attributes of fitness for use. So first, you have the quality of design. So there may be many grades of quality. So quality, second is the quality of conformance. So provide the proper training, products that maintain specification tolerance or motivation. And next is the availability. So this is the reliability and maintainability. Then fourth is the safety, the potential hazards of product use, and the fifth is the failed use. So this refers to the way the product will be used by the customers. Okay, so Dr. Duran also stressed the cost of quality and the legal implications of quality. And he also believes that the contractor's view of quality is conformance to specification, whereas the customer's view of quality is fitness for use when deliver and value. Okay, so the third major contributor of to quality was Philip B. Brosby. So Brosby developed his 14 steps to quality improvement. And aside of that 14 steps, he also had his 4 absolutes of quality. So, unsa man yung mga absolutes of quality? So, quality means conformance to requirements. Quality comes from prevention. Quality means that the performance standard is zero defects. Then quality is measured by the cost of non-conformance. So, Crosby found that the cost of not doing things right the first time could be appreciable in manufacturing. The price of non-conformance average 40% of operating cost, no? So that's what Crosby found. Now let's go to the evolution of quality concepts. So um, quality concepts, the project manager has ultimate responsibility for quality management on the project. So quality management has equal priority with cost, and however the direct measurement of quality may be the responsibility of the quality assurance department or the assistant project manager the for quality. Okay, so Kersner traces the development of quality through major movements. So based on inspection based quality. So this is the post production checking, meaning you are going to inspect the product, review and verify the product, the material or output after the production process has been completed, or meaning it is the inspection of the finished product if it's in a manufacturing company. No, so uh, they check the product after, or it's a total, the finished product, I mean. Okay, they also check the defects of the product if there are, and the in for example in a food production also, so they're checking the expiry dates, the packaging seals, and weight compliance after the production. Next, we have the Statistical Quality Control, or SQC. It is a systematic approach to monitor and control production processes using statistical techniques to ensure that the output meets quality standards. Okay, so this also influenced the by Dr. Edward Deming and by Dr. Duran. So both these the two influential quality figures, they considered quality management. They are considered as the quality management pioneers. So, but they approach quality from slightly different perspective. So, according to Deming's approach, which is the statistical process control, or the SPC, and continuous improvement in quality management, or the PDCA cycle. So their key concepts, the key concept is this use of control charts. So this is to monitor the process variation and identify whether the process is in a state of statistical control. And they also have the distinctions between types of variation. Okay, so have the common cost and the special causes. And his PDCA cycle, the continuous improvement cycle of quality. And also the emphasis on management responsibility. So for Dr. Duran's approach in SQC, so it is focused on quality as fitness for use and introduce managerial aspects of quality, emphasizing planning, control, and improvement. The next, there is this total quality management, or the TQM. It is a comprehensive management approach that focuses on continuous improvement of processes, products, and services by involving all employees in an organization with the goal of achieving customer satisfaction. So in simpler terms, TQM is about doing things right the first time, every time, and improving continuously, not just in production, but all in all aspects of the organization. So, this is an organization-wide effort focusing on long-term success through customer satisfaction. Then there's also the evolution of Six Sigma. So Six Sigma is a data-driven methodology for improving business processes by systematically reducing defects, variability, and errors to achieve near perfect quality. So the term Six Sigma comes from statistics. So sigma, this represents the standard deviation, so a measure of process variation. Now, Six Sigma quality means the process produces only 3.4 defects per million opportunities, or DPMO, which is extremely close to zero defects. Then there's this lean thinking. Okay, so lean thinking, this is also a management philosophy and methodology focused on maximizing value for the customer while minimizing waste in processes. So it originated from the Toyota production system and is widely used in manufacturing services and even healthcare or IT today. So the core idea is simple. So do more with less, less time, effort, resources, and waste, while delivering greater value to the customer. Now, let's go to quality management concepts. So from a manager's perspective, there are six quality management concepts that should exist to support each and every project. So these are the quality policy, quality objectives, quality assurance, quality control, quality audit, and a quality program plan. Okay, so we'll discuss it one by one. So ideally, these six concepts should be embedded within the corporate culture. So quality policy is a document that is typically created by quality experts and fully supported by top management. So the policy should state that the quality objectives, the level of quality acceptable to the organization, and the responsibility of the organization's members for executing the policy and ensuring quality. Okay, it's a guiding document supported by the top management that sets the principles and commitment to quality. So a quality policy would also include statements, no, by top management pledging its support to the policy. So as what I've said, it is a document supported by the top management. So the quality policy is instrumental in creating the organization's reputations and quality image. Okay, so many organizations successfully complete good quality policy, but immediately submarine the good intentions of the policy by delegating the implementation of the policy to lower level managers. So the implementation of the quality policy is the responsibility of top management. So top management must walk the walk as well as talk the talk. Employees will soon see through the rules of a quality policy that is delegated to middle managers while top executives move on to more crucial matters that really impact the bottom line. So, a good quality policy will be a statement of principle stating what, not how. Promote consistency throughout the organization and across projects. Provide an explanation to outsiders of how the organization views quality. Provide specific guidelines for important quality matters. And provide provisions for changing or updating the quality or the policy. Okay? So next is the quality objectives. So quality objectives are a part of an organization's quality policy and consist of specific objectives and a time frame for completing them. Okay, so the quality objectives must be selected carefully. Selecting objectives that are not naturally possible can cause frustration and disillusionment. So, example of acceptable quality objectives might be to train all the members of the organization on the quality policy and objectives before the end of the current fiscal year to set up baseline measurements of specific processes by the end of the current quarter to define the responsibility and authority for meeting the organization's quality objectives down to each member of the organization by the end of the current fiscal year and the like. So, good quality objectives should be obtainable, define specific goals, be understandable, and state specific deadlines. Okay. Now, next is the quality assurance. So, it is a collective term for the formal activities and managerial processes that attempt to ensure that products and services meet the required quality level. So, quality assurance also includes efforts external to these processes that provide information for improving the internal processes. It is the quality assurance function that attempts to ensure that the product project scope, cost, and time functions are fully integrated. So, the Project Management Institute guide to the body of knowledge refers to quality assurance as the management section of quality management. So this is where the area where the project manager can have the greatest impact on the quality of his project. The project manager needs to establish the administrative processes and procedures necessary to ensure and often prove the scope statement conforms to the actual requirements of the customers. The project manager must work with his team to determine which processes they will use to ensure that all stakeholders have confidence that the quality activities will be properly performed. All relevant legal and regulatory requirements must also be met. So, a good quality assurance system will identify objectives and standards, be multifunctional and prevention oriented, plan for collection and use of data in a cycle of continuous improvement, plan for the establishment and maintenance of measures, and include quality audits. Okay, next is the quality control. So, quality control is a collective term for activities and techniques within the process that are intended to create specific quality characteristics. Such activities include continual monitoring processes, identifying and eliminating problem causes, use of statistical process control to reduce the variability and to increase the efficiency of processes. So, quality control certifies that the organization's quality objectives are being met. Okay? Then, quality control, as the technical aspects of quality management, The project team members who have specific technical expertise on various aspects of the project play an active role in quality control. So they set up the technical processes and procedures that ensure that each step of the project provides a quality output from design and development through implementation and maintenance. So each step's output must conform to the overall quality standards and quality plans, thus ensuring that quality is achieved. A good quality control system will select what to control, set standards that provide the basis for decisions regarding possible corrective action, establish the measurement methods used, compare the actual results to the quality standards, act to bring non-conforming processes and material back to the standard based on the information collected, and monitor and calibrate measuring devices that include detailed documentation for all processes. Then the fifth one is the quality audits. So a quality audit is an independent evaluation performed by qualified personnel that ensures that the project is conforming to the project's quality requirements and is following the established quality procedures and policies. A good quality audit will ensure that the planned quality for the project will be met, the products are safe and fit for use, all pertinent laws and regulations are followed, data collection and distribution systems are accurate and adequate, then proper corrective action is taken when required, then improvement opportunities are identified. The last but not the least is the quality program plan or the quality plan. The quality plan is created by the project manager and project team members by breaking down the project objectives into a work breakdown structure. So, using a tree like diagramming technique, the project activities are broken down into lower level activities until specific quality actions can be identified. The project manager then ensures that these actions are documented and implemented in the sequence that will meet the customer's requirements and expectations. This enables the project manager to assure the customer that he has a roadmap to delivering a quality product or service and therefore will satisfy the customer's needs. So a good quality plan will identify all the organization's external and internal customers, cost the design of a process that produces the features desired by the customer, bring in suppliers early in the process, so cause the organization to be responsive to changing customer needs, prove that the process is working and that quality goals are being met. To verify that the product or service meets the customer's requirements, it is necessary to measure the cost of quality. In Harold Kirshner's project management framework, the cost of quality is a key concept in project quality management, emphasizing that quality has a measurable cost and must be managed proactively to avoid costly failures. So, Kirshner's aligns the broader total quality management, the TQM, and PMBOK principles by breaking the cost of quality into four components. So we have first the prevention cost. So this cost incurred to prevent defects or failures before they occur. So from the word itself, prevention, this is to prevent or avoid the production of poor quality deliverables. So example of this is quality planning and training. So this is to ensure that everyone in the team understands how to deliver quality right the first time. So most defects and rework come from unclear requirements, lack of knowledge, or inconsistent processes. So how will you prevent costly mistakes? So this is where the training and planning comes in. So quality planning defines the standards, the procedures, and responsibilities upfront, and the training ensures the team knows how to apply those standards set by the quality planning. Okay. Then next we have the appraisal inspection cost. So these costs related to measuring, auditing, and monitoring to ensure project outputs meet quality requirements. So it is a detection or an early problem detection before they reach the customer. But this is not a prevention. So example of this is the quality control inspections. So most companies have these quality inspections. So these are activities where deliverables, processes, or components are checked against defined quality standards or against the customer's specific requirements. This is to detect defects before they reach before it was reached to the customer. Okay. So next, we have the internal failure cost or cost arising from defects found before deliverables are handed over to the client or the end user. So the goal of this cost is to minimize the cost by catching the defects early. So this is an internal defects detection. So example is a rework and design corrections, like performing the task again because the first attempt did not meet the specifications or the standards. So this is due to the errors, the mistakes, or miscommunication during the execution. So for example, in a manufacturing company, so you have detected that there's a problem or there's a defect within the process, or the product was already kanang done or it was already finished. So you have detected the problem, or you have detected that the item or the product did not meet the specifications or the standards. So you need to redo or refabricate the parts or the item. Why? Because it failed the inspection. So another cost. So the cost of redoing again. So that is what they call the internal failure cost. Next is the external failure cost. So this cost due to defects after the product or service that has been delivered to the client. So this is now the external defects detection. So the item was already received by the customer, and the customer detected the customer is the one who have detected the item that has a defect. So the company should avoid this cost entirely because it both harms the finances and the reputation of the company. So what are the examples? So they can have the warranty claims or service calls, the penalties or legal claims, loss of customer trust, and project recalls or product returns. So it's a very most expensive and damaging external failure. So this can result to a repeatable damage that overweight or outweighs measurable financial loss. No? Okay. Now, as you can see in the figure, it shows that prevention cost can increase. This is not always the case. So, prevention cost can be decreased without sacrificing the purpose of prevention if we can identify and eliminate the cost associated with waste, such as waste due to rejections of completed work, design flaws, work in progress, improper instructed manpower or improper assigned manpower, improper utilization of facilities, and excessive expenses that do not necessarily contribute to the project. Okay, now let's go to the 7 basic quality tools. Okay, the 7 basic quality tools are emphasized as fundamental techniques for problem solving and quality improvement. So these tools help project teams analyze processes, identify root causes of defects, and prevent quality issues. So the first, we have the data tables, or which is called also as a check sheet. So the purpose of this, it is a form or a structured form for collecting and analyzing data systematically. Okay, so check sheets are simple but powerful for spotting patterns and trends early. So as you can see in the example of an attribute passed or failed data figure for the correctness of invoices, from this simple check sheet, several data points become apparent. The total number of defects is 34. The highest number of defects is from supplier A, and the most frequent defect is incorrect test documentation. We can subject this data to further analysis by using Pareto analysis, control charts, and other statistical tools. So after identifying a problem, it is necessary to determine its cause. So this is where the cause and effect analysis comes in, or what we also called as the Ishikawa or fishbone diagram. So it is used to identify categorize and analyze potential root causes of a problem, helping project teams prevent or correct quality issues efficiently. So cost and effect analysis uses diagramming techniques to identify the relationships between an effect and its causes. So the structure of the diagram, as you can see, the head the head of the fish, this is represent the problem or effect or the undesired outcome. Now the bones as you can see are, we have the six bones. The top major or the top major six bones represents the category major categories of causes, and the smaller bones on each top major categories, that represents the sub-causes under each category. So the example figure demonstrates the basic fishbone diagram. So 6 steps are used to perform a cost and effect analysis. Step 1, identify the problem. So this step involves the use of other statistical process control tools such as Pareto analysis, histograms, and control charts, as well as brainstorming. So the result is a clear, concise problem statement. Now, step 2, select an interdisciplinary brainstorming team. So the team is selected based on the technical, analytical, and management knowledge required to determine the causes of the problem. So some companies have also a quality team. That's what they call quality team. Then next, the step 3, draw a problem box and a prime arrow. So the problem contains the problem statement being evaluated for cost and effect. The prime arrow functions as the foundation of the major categories. Okay? Now, step 4, specify major categories. So, identify the major categories contributing to the problem stated in the problem box. So, the 6 basic categories for primary causes of the problems are most frequently the personnel, or which we call also as a manpower. Then we also have the method, materials, machine, measurements, and the environment as shown in the figure. Now, step 5, identify defect causes. When you have identified the major causes contributing to the problem, you can determine the causes related to each of the major categories. There are 3 approaches to this analysis: the random method, the systematic method, and the process analysis method. So when you're going to use the random method, you need to list all 6 major causes contributing to the problem at the same time. So identify the possible causes related to each of the categories as shown in the figure. Okay. Now, next is the histogram. So a histogram is a graphical representation of data as a frequency distribution. So this tool is valuable in evaluating both attribute, the pass or fail, and variable, the measurement data. So histograms offer a quick look at the data at a single point in time. They do not display variance or trends over time. A histogram displays how the cumulative data looks today. So it is useful in understanding the relative frequencies of the data and how those data are distributed. The figure illustrates a histogram of the frequency of defects in a manufacturing process. So these are examples of manufacturing process failures wherein they record the frequency of failed processes. Okay. Now, Pareto analysis or the Pareto chart, this is what you also called as the 80-20 rule. So a Pareto diagram is a special type of histogram that helps us to identify and prioritize problem areas. The construction of a Pareto diagram may involve data collective from data figures, no, like that. As you can see in the figure, it's a check sheet. You need to um, write the data you have collected. Now, maintenance data, repair data, parts scrap rates, or other sources. So, by identifying types of nonconformity from any of these data sources, the Pareto diagram directs attention to the most frequent occurring element. So, there are 3 uses and types of Pareto analysis. The basic Pareto analysis identifies the vital few contributors that account for most quality problems in any system. The comparative Pareto analysis focuses on any number of program options or actions. The weighted Pareto analysis gives a measure of significance to factors that may not appear significant at first, such additional factors as cost, time, and criticality. The basic Pareto analysis chart provides an evaluation of the most frequent occurrences. For any given data set, by applying the Pareto analysis steps to the material receipt and inspection process described in that figure 20-4, we can produce the basic Pareto analysis as demonstrated in figure 20-15. This basic Pareto analysis quantifies and graphs the frequency of occurrence for material receipt and inspection, and further identifies the most significant based on frequency. A review of this Pareto analysis for frequency of occurrences indicates that supplier A is experiencing the most rejections with 38% of all the failures. Pareto analysis diagrams are also used to determine the effect of corrective action, or to analyze the difference between two or more processes and methods. As you can see in the figure 20, in the figure, okay, another pictorial representation of process control data is the scatter plot or scatter diagram. A scatter diagram organizes data using two variables, an independent variable and a dependent variable. These data are then recorded on a simple graph with x and y coordinates, showing the relationship between the variables. So as you can see in the figure 20-17, this displays the relationship between two of the data elements from the solder qualification test scores. The independent variable experience in months is listed on the x-axis. The dependent variable is the score, which is recorded on the y-axis. These relationships fall into several categories as shown in figure 20-18. In the first scatter plot, there is no correlation. The data points are widely scattered with no apparent pattern. The second scatter plot shows a curvilinear correlation demonstrated by the U shape of the graph. So the third scatter plot has a negative correlation as indicated by the downward slope. The final scatter plot has a positive correlation with an upward slope. So from figure 20-17, we can see that the scatter plot for soldier certification test is somewhat a curvilinear. The least and the most experienced employees scored highest, whereas those with an intermediate level of experience did not relatively poor, or did they experience the relatively poor. The next tool is the trend analysis. This will help clarify and quantify this relationship. So trend analysis is a statistical method for determining the equation that best fits the data in a scatter plot. So trend analysis quantifies the relationships of the data, determines the equation, and measures the fit of the equation to the data. This method is also known as curve fitting or least squares. So trend analysis can determine optimal operating conditions by providing an equation that describes the relationship between the dependent, which is the output, and the independent, which is the input variables. So an example of this data set concerning experience and score on the soldier certification test as shown in figure 20-819. So the equation of the regression in line or trend line provides a clear and understandable measure of the change caused in the output variable by every incremental change of the input or independent variable. Using this principle, we can predict the effect of changes in the process. So one of the most important contributions that can be made by trend analysis is forecasting. So forecasting enables us to predict what is likely to occur in the future. Based on the regression line, we can forecast what will happen as the independent variable attains values beyond the existing data. Okay, now next we have the control charts. So the use of control charts focuses on the prevention of defects rather than the detection and rejection. So in business, government and industry, economy and efficient are always best served by prevention. So it costs much more to produce an unsatisfactory product or service that it does to produce a satisfactory one. So there are many costs associated with producing unsatisfactory goods and services. So these costs are in labor materials, in facilities, and in loss of customers. So the cost of producing a proper product can be reduced significantly by the application of statistical process control charts. So control charts and the nominal distribution. So the construction, use, and interpretation of control charts is based on the nominal statistics distribution as indicated in figure 20-20. The center line of the control charts represents the average or mean of the data, which is the x, and the upper control limits, which is the UCL, and the lower control limits, which is the LCL, represents this mean plus and minus 3 standard deviation of the data. So either the lowercase s or the Greek letter sigma represents the standard. So control charts analysis determines whether the inherent process variability and the process average are at stable levels, whether one or both are out of statistical control or not stable, or whether appropriate action needs to be taken. Another purpose of using control charts is to distinguish between the inherent random variability of a process and the variability attributed to an assigned cause. So there are two types of control charts. We have the variable charts, which we use with continuous data, and attribute charts for use with discrete data. So each type of control chart can be used with specific types of data. So as you can see in table 20-4, there's a provide a brief there's a brief overview of the types of control charts and their applications. So variable charts is a powerful control chart that we can use when measurements from a process or variable. For example, a variable data are the diameter of a bearing or electrical output or the torque of a fastener. So while attributing charts as an attribute data having only two values, the conforming and non-conforming or pass or fail, but they can still be counted, recorded, and analyzed. So some examples are the presence of a required label, the installation of all required fasteners, the presence of solder drips, or the continuity of an electrical circuit. So we also use attribute charts for characteristics that are measurable. If the results are recorded in a simple yes or no fashion, such as the conformance of a shaft diameter when measured on a go-no-go gauge, or the acceptability of threshold margins to a visual or check gauge. So the use of statistical control charts is aimed at studying specific ongoing processes in order to keep them in satisfactory control. By contrast, downstream inspection aims to identify defects. In other words, control charts focus on prevention of defects rather than detection and rejection. Okay, so acceptance sampling is a quality control method. Uh, we also have this acceptance sampling, no? So this is a statistical process of evaluating a portion of a lot for the purpose of accepting or rejecting the entire lot. So it is an attempt to monitor the quality of the incoming product or material after the completion of production. Okay, now next, this will be, so this is where my report ends, and on the next slide it will be discussed by Miss Mary Rose. Okay, thank you.
Good afternoon, everyone. My name is Mary Rose Quizon. I'm going to continue the discussion of Ma'am Julie Pearl Espinosa. Now let's discuss into more advanced quality management methodologies, which are the Six Sigma and continuous improvement. Six Sigma focuses on reducing process variation and enhancing process control. Kirsner stresses continuous improvement or Kaizen as a mindset for enhancing quality over time. These two methodologies or approaches, while distinct, they are highly complementary. Six Sigma is the data driven methodology focused on minimizing variation and defects in processes, aiming for near perfection. It uses statistical methods to identify and eliminate the root causes of problems, while continuous improvement complements Six Sigma by fostering a culture of ongoing incremental enhancement, ensuring that improvements are not one time events but become an ingrained part of the organizational culture. Think of Six Sigma as providing the powerful tools for large scale process improvements, while Kaizen provides the sustained momentum for continuous optimization. Now let's tackle about leadership and responsibility. So the success of both Six Sigma and Kaizen hinges on strong leadership and a shared sense of responsibility. As highlighted in leadership and responsibility, effective leadership establishes a quality focus organizational culture. So this involves setting clear expectations, allocating resources to quality initiatives, and holding individuals and teams accountable for achieving quality objectives. The project manager plays a key role in integrating quality into every phase of project management, ensuring that quality is not just a concern for specialized teams but a shared responsibility across the entire organization. Quality leadership must come from the top. Responsibility for quality lies with everyone involved, not just the QA teams. The project manager also plays a critical coordinating role, ensuring all team members understand and follow quality standards. Ultimately, all quality improvement efforts aim to enhance customer satisfaction. The central theme of quality and customer satisfaction. So, by minimizing defects, reducing variation, and continuously improving processes, we directly address customer needs and expectations. Remember that customer satisfaction is not merely about meeting minimum requirements, but about exceeding expectations and delighting customers, fostering loyalty and repeat business. So, quality must be defined from customers' perspective, and a deliverable may meet specs but still fail if it doesn't satisfy customer needs or expectations. To fully realize the benefits of quality management, it is crucial to integrate quality into every phase of the project lifecycle. As integration with project management, this entails defining clear quality objectives from the project's outset, incorporating quality checks throughout, and using quality metrics to monitor performance. This proactive integrated approach ensures that quality is not an afterthought but an inherent part of project's overall success. So quality should be integrated into all aspects of the project lifecycle from initiation to closure. Project success increasingly depends on quality outcomes, not just time and cost adherence. So, quality circles and TQM, or total quality management. So, quality circles and TQM introduces two key approaches to fostering culture of continuous improvement. Quality circles empower employees to identify and solve quality problems in their own work areas. And total quality management, or TQM, represents a more holistic approach involving a systematic and organization wide commitment to quality. And also, TQM emphasizes continuous improvement, employee empowerment, and shared responsibility. So, quality circles encourages the use of small group problem or solving teams, which is what we call quality circles. TQM fosters a culture of quality across the organization. The shift from reactive to proactive quality management is central to modern emphasis. Instead of simply reacting to problems after they occur, modern approaches focus on prevention. So, this proactive approach involves identifying and mitigating potential risk, establishing robust processes to ensure quality, and focusing on value creation for both the organization and the customer. Promotes shifting from inspection quality to preventive, proactive approaches. Emphasizes value creation, risk reduction, and stakeholder satisfaction as essential outcomes of modern quality management. So, why understand quality management? Effective quality management translate into tangible benefits including higher quality products and services, improved communication, increased employee morale and productivity, significant cost savings through defect prevention, better decision making based on data, stronger team accountability, and enhanced organizational reputation. These benefits underscore the importance of viewing quality management not as a cost but as a strategic investment. So we have here again why quality management is important. The first thing is customer-centered success. Second is strategic integration. The third one is continuous improvement. The fourth one is cost reduction. The fifth one is informed decision making. The sixth one is team accountability. And then we have the supports organizational reputation. The importance of quality management expands on these benefits, providing a deeper understanding of the positive impact of robust quality management system. So each benefit, like customer-centered success. So this is quality is defined by the customer. Understanding quality management ensures the project outcomes meet or exceed customer expectation, which is essential for client satisfaction and repeat business. And the second one is strategic integration. So, quality management is not just about compliance, it's a strategic element that integrates with time, cost, and scope management. It ensures the entire project lifecycle aligns with organizational goals and stakeholder needs. The third one is continuous improvement. So, Kirstner emphasizes that quality management supports continuous improvement. Lesson learned and performance metrics are used to refine processes, reduce waste, and drive efficiency in future projects. The fourth one is the cost reduction. So, improve quality, lower the cost of non-conformance like rework, scrap, or delays. Kirzner points out that high quality outputs reduce long-term cost and enhance profitability. And the fifth one is informed decision making. So, understanding quality management promotes data-based decision. It equips managers with tools like control charts, Pareto analysis, and audits that provide insights into process performance. And the sixth one is team accountability. So, quality is everyone's responsibility, not just for one person, but for everyone's responsibility. So, understanding the system encourages collaboration, ownership, and accountability across project roles, not just among quality control staff. And the last one but not the least, that is the supports organizational reputation. So a well-managed quality system strengthens the organization's brand, trust, and competitiveness. Consistent delivery of high quality results improves stakeholder confidence. Okay, now we're going to tackle the evolution and focus. So Kirsner emphasizes that modern views of quality have shifted from inspection, like finding defects, to prevention and strategic management. So key ideas include quality is a continuous improvement process. Quality occurs at project initiation, not just during execution. Quality is everyone's responsibility, not just production teams. Improved quality can reduce costs and increase business value. So, evolution and focus summarizes the historical progression of quality management practices. So, this evolution demonstrates a clear shift from a reactive, inspection driven approach to a proactive, preventive model centered on continuous improvement. Understanding this evolution highlights the importance of adapting quality management strategies to remain relevant and effective in the dynamic business landscape. So here's the benefits of quality management. So the first one is improves product and service quality, ensures outputs meet standards. Next is enhances communication, promotes teamwork and transparency. Next is boost employee performance, encourages ownership and morale. And the next one is drives process improvement, reduces errors and increases efficiency. And lower costs, minimizes waste, rework, and failure expenses. And the last but not the least is supports better decision. So, benefits of quality management summarizes the key advantages of implementing a comprehensive quality management system. This includes improvements in product and process quality, increased efficiency, substantial cost savings through defect prevention, significantly enhance customer satisfaction, and a more robust organizational reputation. So, this summary reinforces the compelling return on investment associated with prioritizing quality management. So, in conclusion, Gerstner emphasizes that modern quality management is no longer just about product inspection or compliance. It is a strategic organization wide commitment that starts at the top and is integrated throughout the project life cycle. Here's the suggestions for effective quality management. So, the first one is develop a strong quality culture, promotes organizational values that prioritize quality and accountability at all levels. The second one is involve everyone. Encourage participation through quality circle suggestions, programs, and team ownership of quality outcomes. The third one is plan for quality early. So integrate quality planning into project initiation, not just during execution. The fourth one is use data-driven tool. Implement statistical tools like control charts, Pareto analysis, and so on to monitor, measure, and improve performance. And the fifth one is conduct regular audits, perform internal and external audits to ensure adherence to standards and to identify areas for improvement. And the sixth one is focus on training and education, provide continuous training on quality principles, tools, and procedures to build capability across the team. Seventh one is document and apply lesson learned, maintain a system for capturing, reviewing, and applying lesson learned to future projects. That's the end of our presentation about quality management. Thank you so much for listening.